In this video, we're going to look at a problem that most people have probably never thought of. The problem is my friend N and I leave from the same location. N travels north at 60 miles per hour and I drive east at 30 miles per hour. After 1 hour, how fast is the distance between N and myself growing? To solve this problem, we need to use related rates and implicit differentiation. Implicit differentiation says that our variables are implicitly dependent on other variables, usually time. In this problem, N and my distance from each other is dependent on time. Since N is driving at 60 miles per hour, after 1 hour, N has traveled 60 miles north, and after 1 hour, I've driven 30 miles east. In this case, north is our y-axis, and east is our x-axis. The distance between us can be described as distance squared equals x squared plus y squared. Since we want to know how fast our distance is growing, we need to take a time derivative. We can do this on our distance squared equals x squared plus y squared to simplify things. Taking the time derivative of this, we get 2 times distance times the time derivative of distance equals 2 times x times the time derivative of x plus 2 times y times the time derivative of y. We can cancel out our 2's and just get distance times time derivative of distance equals x times derivative of x plus y times time derivative of y. We need to solve for the time derivative of distance since this will tell us how our distance is growing between us. To do this, we need to get our actual distance and then plug in what variables we have. Our distance we can solve for is the square root of 30 squared plus 60 squared, as I've gone 30 miles east and N has gone 60 miles north. This simplifies down to 30 times the square root of 5. Now, we just plug everything in, so we get 30 times the square root of 5 times our time derivative of distance equals how far I've gone in the x direction, which is 30 miles, times our velocity, which is 30 miles per hour, plus how far N has gone north, which is 60 miles, times N's velocity, which is 60 miles per hour. Once we plug in everything and solve, we get that our time derivative of distance is 30 times the square root of 5. Thus, our distance is growing at 30 root 5 miles per hour, or about 67.08 miles per hour after 1 hour. I hope you found this interesting, and thanks for watching.